All right, indeed. I'm going to take you on the picnic journey, how we went from being a cloud-native company to hybrid and back again. And yes, that is indeed a Hobbit reference. All right, let's get started. So I'll do this based on 3 learnings that we had during this journey. So first of all, your start design doesn't have to be your target design. So really keep on iterating, keep on considering what do you really need. The second, that the best testing is actually done in production, but obviously you need to know what the hell you're doing. And then thirdly is that when you're actually migrating, you need to be prepared for everything going wrong anywhere, and at least make sure that you have a good plan in place and you are able to take the risks into consideration. But first, let me quickly introduce myself. I'm Tyko Kieskamp, as indeed mentioned, thank you. I was the project lead of this migration of how we went and took our on-premise workloads that we had to the cloud. Let me first quickly introduce you to Picnic and set a little bit the stage. So who of you here know Picnic? Raise your hands. Okay, that's actually quite a bit. Raise your hands if you actually order at Picnic. A little bit less. I think we can get that number up. Hopefully at the end of the night you're convinced, at least if you live in Netherlands, Germany or France, because not yet in the other countries. But first, what do we do? So we are an online supermarket. I lost my screen there. Okay, the online supermarket. That means that you can order your groceries and we deliver it the next day at your house. So if it's your general groceries or the beers you want for the Netherlands-France match of tonight, up to you. You can order. And we take this old milkman model coming by the door and putting it in a new modern jacket by enabling it and empowering it through technology, data, and innovation. So we're really a product-focused company. And that means that we really wanted to grow that business model. And we took a very cloud-native approach for this. So that allows us to quickly develop and not be blocked by any maintenance and stuff like that. So we took full advantage of that by allowing us to go quick and having really reliable operations. So you don't have any business disruptions down the line. And I think the third thing is maybe even most important. It really allowed you to attract the right talent on the SRE level. So really people focus on helping you grow for the future and not just maintaining whatever stack you have in place. So these are the key reasons that we went cloud native in the first place. Now let's go to the problem statement. So we take all of the products that we get from our suppliers, and it's, somebody orders, and we need to get them the goods. And that is what we do in fulfillment centers. So we take them and we started with the manual processes. So people actually walking with cars past these lines and lines of goods and putting them in the crates so that they can be delivered. You know, helps you scale because it was actually fairly quickly to set up. I think 3 months to pop up a new one, and actually not that expensive. It's still a lot of money, but you know, doable. But to really get into the future, need to keep innovating, need to keep automating. And that's what we did with our fulfillment center automated, our FCA, which is a lot of conveyors, as you can see, and a lot of crates going around. While the first set of manual fulfillment centers, we had the workloads in the cloud. For this one, we had it on-premise. Why would we do that? You know, a cloud-native company, the most innovative project that we had, and we put it on-premise, that doesn't make too much sense. Well, there are a couple reasons, so 3 to be exact. So first of all, complexity. We didn't know what we're doing. We decided to develop all the code for this ourselves, but we have never done it. We had experience with the manual ones, but not with the automated. And the partner that we teamed up with had a lot of experience creating the hardware, the sites, but not too much with actually running stuff in the cloud. So a risk we weren't willing to take. And at that moment, we actually didn't have very good connectivity from that site to our cloud provider. So we were taking actually pretty big risks on that angle as well. And then the last thing, also mentioned actually in the last slide, and I'll iterate on this one a bit more extensively, is latency. Because this automated fulfillment center has very strict latency requirements, and running in the cloud just has a longer latency, a bigger latency than doing something on-premise. So let's dive into that one. I'll quickly let you show the video. So what we see here is one of the random locations in our automated fulfillment center. So we have these kilometers of conveyors, and a whole bunch of crates are going on this. And these crates need to be somewhere because we have a process around that. So these travel along that path. What you see at the top right is a red blink. We have a scanner there, and it scans the tote, scans the crate, and says, hey, I need to go this direction or that direction. And we have about 250 milliseconds between the scanner and the diversion zone to actually send it one way or the other. So that means that our systems have 250 milliseconds to decide which direction this crate should go in. I'm not sure why it's cutting out every time, but we'll make it do. And that means that if you add any latency there, it can go wrong. So if it misses this divert, it's not too great. It can happen once or twice, that's okay. But if it happens a lot of times, you get very inefficient. And even in the worst case, you can get a gridlock. I like to compare this a little bit with highway. If you're driving and you miss your exit, not too great. You're like 5, maybe 10 minutes late after a detour at your destination. But if suddenly everybody misses their highway exit, then you have a traffic jam in one highway and then empty lanes in the other. That's the same thing that can happen here. So now we know why, but well, let's get on, because we actually did something, otherwise I wouldn't be standing here. So first of all, your starting design doesn't have to be your target design. So after we adopted these on-premise workloads, we actually noticed that our benefits that we got from being cloud native disappeared. Our velocity went down. We needed to do every feature development twice. Our reliability went down. We had a whole bunch of incidents that we didn't experience before, and we actually didn't have much experience with dealing. And also, it's a lot more difficult to attract the right level of talent. We weren't doing something fancy with these workloads, we're just running them. So it's a lot more difficult to attract somebody by giving them the challenge to just maintain an on-premise server, as well as being a cloud-native engineer. So it's a lot more difficult. So, and this is a slide that I'm certain a lot of people on the cloud providers use a bit, or at least the right side of it. Your velocity goes up if you migrate to the cloud, and your TCO goes down. We're in a unique situation. We were cloud native. We actually saw this happen to us. Our velocity went down, and the total cost of ownership went up. So this migration back from our on-premise stuff to the cloud should solve that, should bring back the velocity and lower the cost for us. We're 12 months later by this point. We actually had some experience running this automated center, and we solved 2 out of the 3 problems already. So complexity, well, we've been running it for 12 months. We know how it worked. We're pretty confident on being able to run stuff in the cloud. As well as we solved the connectivity. We now had a private link from the site to our cloud provider. The only thing that we still need to tackle is the latency problem. Point number 3, best testing is done in production. I think some of you already have an indication where this goes to, but yes, we tested by applying synthetic latency in our production site and seeing if stuff would break. So we, between our on-site machinery and our message broker, we applied 50 milliseconds of latency, which is the expected impact that a cloud migration would bring. This was still with the message broker and our applications being on-premise, to be clear. So we just simulated the effect of latency. We went to our operations team and said we want to test this. They said, what will go wrong? Well, maybe you will see some impact, but we'll be right there with you. If we break stuff, you yell, we roll back. And they said, OK, I still don't understand fully why, but sure, they did. First thing you do after you test it, did we actually apply the latency and did it behave as expected? What you see here is the number of observations and the round trip time it took for a call to come back. And I want to focus it on the red area because that's where the interesting calls were. Blue is without any latency applied, and you see a nice shift from 30 milliseconds when we applied 30 and 50 milliseconds when we applied 50. So the median deviated nicely. It's not that there was suddenly twice that amount applied because it was going back and forth twice for whatever reason. And another interesting observation here is that if you look in the long tail, there's not actually that much of a difference. And that was actually also a good thing, because that meant that we also had this graph as a result. So what you see here is actually the actual impact. So the number of missed diverts, I showed you the video a little bit earlier, per 5 minutes. And you can see that there is actually no substantial difference over time after we applied 30 milliseconds or 50 milliseconds. There was no difference. If you are not that great in data analytics, you would say it's even better to run at 30 milliseconds. That's not the case, but at least you get the idea. So, testing done. We could do it. We wouldn't see any differences on the latency side, so we solved all of our issues. Now we could get to the actual migration. And we did that by preparing for failure in all parts, making sure we had a good plan, and that we had the team required to actually execute on the plan. And that also we put everybody in a position where we could make risk treatments at any moment. Because that's, I think, a very, very important learning that we had. And I'll actually have a nice story in a second. But firstly, how did we limit at least the scope so it's manageable? Because if you'd want to do all the migrations at once, that can be difficult. I didn't mention this earlier, but we are running a 27 operations, so 20 hours, 7 days, at these automated FCs. And in some cases, they even add 1 or 2 more hours during the night just to get ahead of the work for the next day. And we were running already at 70–80% of our total capacity, and we're constantly scaling still to get to 100, which we achieved by now. So what I'm trying to say, there was no margin for error. And if we didn't deliver, and if there was still a broken site after the maintenance window, there was a big problem, because we would have had to cancel orders to our customers, and that's the last thing we would want. So we needed to split, actually, not only for simplicity, but also for time's sakes, the migrations into multiple windows. So we had 8 databases, 1 message broker, 12 applications, and to be fair, also a whole bunch of supporting stuff that we needed to migrate. And we decided to go with 4 windows. So first, start off easy. Just do 1 database. Get everybody started, get a little bit of know how this works, how such a migration works. Then proceed with the other 9. Then, actually, Windows C was the most critical, because we did the message broker and 2 of the most important applications, so that was the risky one. And then the final migration, completing it by the rest of the applications. So we split it up, manageable points, and then we started to execute. We made sure we had a good team assembled. So I think this was a very critical part, because we had a migration team who prepared all the steps that we needed to do, had a very extensive runbook and knew it inside and out. Then we had also operations team who were present with us on site to make sure that they could actually test after we were done that the site behaved as expected. So yes, we could check virtually if everything looks fine in our monitoring system, etc., etc. But at some point you need to have on-floor confirmation. And initially we didn't have too extensively this third team, this firefighting team of experts. But we learned after our first window that it's actually very essential to have a very diverse team of experts so you can tackle any issue that comes on your way. We faced some issues in the initial window. Eventually we managed to fix it, but a very big learning for us, at least at that moment. So we gathered this entire team, split it up in different windows, and we were good to go. Now I'm going to tell you a nice wartime story of how this scanner caused us to roll back. I really don't like this scanner, by the way. Specifically, what happened is we were in the final maintenance window, so maintenance window D. We were 3 hours in, and actually until that point, everything went well. We migrated our applications, started everything up again, everything seemed to work fine. We saw 1 or 2 minor issues down the line, but nothing too big that we couldn't handle. First checks, everything looked healthy in Kubernetes, and the other checks that we have, they all seemed to connect and talk to each other. Then our operations did some checks, everything looked fine also there. I think it was the second to last check that we were doing with this device, and it didn't work. It just scanned, but nothing happened. So what's a sad moment? It really hit me at that moment, because, you know, final window, almost there, almost done. Effectively the final check that you're doing, and it fails. So we had to roll back. I had one last ace up my sleeve, though, because actually this firefighting team of experts that included somebody who developed the applications for this device, because, well, we do that ourselves as well. So we called her in. It was 3 a.m. in the morning at that time, 1 hour left, and she woke up. She knew this was happening. I informed her beforehand, and you know, she got to our laptop 45 minutes to go. Well, then our migration team, together with this expert, took a look at it, tried to debug as quickly as possible what it was, and we figured it out fairly quickly. Because we had a redirect put into place. So rather than directly pointing to the new DNS, to the new application, we left the old DNS in place, had a redirect there to the new ones. You know, make it simpler, push that part of updating these devices to another moment. But these devices, they, for whatever reason, don't like the redirect. I still don't know why. And to be honest, at this moment, I don't care anymore. But you know, it didn't work. But now we had a solution. We could roll back, or we could just get rid of this redirect, point directly to the new application. At this moment, we had 30 minutes left to go before operations started again. But now we had a plan. So this expert created a new version, deployed it, and pushed it to all of our devices. Let me tell you, I assume this doesn't generally take long, but I swear this night it felt like it took very, very long. And actually, I think it took about 15 minutes to get pushed to the first device, until the first device was actually updated. But at least we had one. So we got that device, and we tested, and yes, finally, it works again. We could scan barcodes, and we would reach our own application, get the information required, etc. So thank God, we made it. It took actually quite some time to push all of these updates to all of the devices, and we were well into overtime by the time that was completed. But at least the time that operations started again, they had enough devices with the new version that they weren't impacted. They could start again and actually had a very successful day afterwards. So this barcode scanner almost caused the rollback. All right. 3 key learnings at the end. So, you know, we completed this redesign. We thought this design we had in the beginning, we need to do this. We figured out along the way it works differently, we can do it better, and we improved upon that. We did the right level of testing. Ideally, you do it in production. Obviously, we also did some testing in our development environment and simulation environment beforehand, but eventually you need to also actually test how it works on the floor. And we prepared for everything could go wrong, and at least have a plan, always have a backup plan to roll back if it doesn't work out. But try, if you can, to solve it instead. Now I want to take you a little bit on, actually, let me stay with this one for a second, because these are the key learnings, and I hope you took some things with you yourself, something that you can use in your own project or your own organization. I think it's generally, don't be afraid, push for improvement, and hope you took something with this. But indeed, you already saw quickly the last slide, but I want to take you quickly on what it actually brought us, because we needed to improve upon our velocity again. We need to improve on our reliability again. We needed to improve upon the talent we could acquire. And we actually did that. So we actually also decreased the cost of this on-premise setup. We played away a lot of developer hours again. We didn't have to do things twice. We had a lot less incidents, and if we had, it's a lot easier and a lot quicker to solve. And lastly, we actually required a lot less external support to actually keep this running. And also our internal team could really focus again on what is important and not maintaining something. And their speed definitely improved upon that again. So that takes me to the entire story. That was our picnic hybrid journey, how we went from being a cloud native to a hybrid company to now being proudly a cloud native company again.